In order to start development activities, first we need to install all the relevant packages within this environment. As my deployment environment, which is env underscore serving, is completely clean and we haven't installed any packages in that environment. So that would be our first step. And before installing packages, you also need to ensure that the package version which we would be using for model deployment would be exactly same to the version which we had used during model training. If we simply go back to our training notebook, you will see that I have used different package version for all the used packages within training pipeline. So you can see that NumPy has a version of 1.19.4, scikit-learn has version of 0.23.2, right? So that's the purpose of keeping track of the version number which we had used during model training, and during the model deployment we'll use the same version of packages, right? And I have already documented all those package version here, right? And we'll simply take that version and we'll install it. So these package version are in sync with training package version, right? So we'll install it, and first we need to install Japa, right? Because we would be needing Japa for AWS deployment. We need Boto3 for communicating with AWS. Then we need NumPy for model training, JobLib for unpacking our model artifacts, scikit-learn for machine learning algorithm, NLTK for text pre-processing, and Flask for building machine learning API, right? We'll press enter and it will install all the required packages, right? We haven't installed any packages which we had used during model training for data analysis, data exploration, or model interpretation, because we don't need those during model prediction, right? At runtime, right? These are mainly for data exploration, analysis, and understanding point of view, right? And here it's just pulling out all the dependencies and trying to install it within our deployment environment, right? So once that would be complete, then we can start local testing with the help of Flask API, right? And once my local testing gets complete, then we will go ahead and deploy our changes to AWS infrastructure. As you can see that my installation is complete, and now we can start doing local testing. So as you can see that my Flask API is simple Python program, and we can simply run it with the help of Python command. So Python predictor.py, press enter. So it will run my Flask API, and you can see that my all the model artifacts have been loaded, and it has launched a deployment server where my Flask API has been deployed. Okay. Now, in order to hit the model API endpoint, what exactly we need to? We need to take this link, right, and provide your /predict endpoint. And in order to test any REST API, the best way to start doing it with the help of Postman. So Postman is very good utility for performing REST API based testing, right? So just download the app. So once download, you would be able to download and install that app. You'll find this type of screen, right? So just click on link, new, you'll find request, click on request, you'll find this type of screen, right? And here you need to select post, right? And here you need to provide the your deployment server path, right? So here http colon 127.0.0.1 colon 5000 port, right? So that's what I have done here, and followed by our class predict endpoint, and that's what we had defined here, right? And in the body you need to provide the content of your body. So that's the format of our JSON payload, right? So we would be having payload as a key, and as a part of value we would be providing list of text, right? So here we are providing a single text containing within a list, right? So that's the part of body. And also you need to select it here JSON, right? So as we would be sending request in JSON format, so select JSON and then click on send. So once you will click on send, you'll find a request here saying that Flask has received that response and successful response has been sent back to client. So in our case the client is the Postman app which we are using for testing purpose. Okay, so just send, click on send. So you can see we have received one request saying that predict endpoint has been accessed and HTTP response code 200 has been sent back to client, right? So that means it's behaving as expected. And you can see that this message has been classified as spam. And I'm getting 93.57 probability that this message falls under the category of spam, and only 6.42% probability as ham message, right? So which looks okay, right? Because it's looked like a spam message. Now we'll test for another layout in which I will be passing some valid message. So like this. So this time I will be passing this message, and hopefully it would be categorized as ham message, not a spam message, right? Just click send and see here you have received probability score of 99.77 probability score that it's a ham message, which is correct, right? And here you will see that one entry saying that my Flask app has received another request from client, and that's a post request, and it has hit predict endpoint, and successful 2000 response code has been sent back to my client. So client in this case is Postman. That's what we have seen here. So that confirms that my Flask app is behaving as expected, and now we are good to go with production deployment. And from the negative testing point of view, if something goes wrong with your Flask app and there are some bugs within your Flask application, then you will see all those sort of errors here, right? So whenever you will send a request, if something is not correct within your Flask application will throw an error, and all those errors would be visible here, right? So in that way you can debug your code locally, and once you are happy with the overall content and the test results, you can go ahead and promote your changes into the cloud, right? So as we have seen that we are getting results for both spam and ham messages correctly. I have randomly taken few examples and I have tested it against the prediction pipeline.